Auzu billahi minash shaitani rajim. Bismillahir rahmanir rahim. Dear students, Assalamu alaikum. I am Dr. Azhar Ali, Assistant Professor, Electrical Engineering Department, Sarhad University, Peshawar, and you welcome back to this study. Dear students, in this first video lecture of week 6 for the course Biostatistics 1, today we are going to learn about measure of positions. Measure of positions mean to measure quantiles. Dear students, quantiles are the numbers which divide the data into equal parts, and there are three types of quantiles. One is called quartile, second is called deciles, and third one is called percentiles. So in this first video lecture today we are going to learn about the two types of quantiles, which is called quartiles and deciles. And in this video lecture I will tell you about these two types of quantiles in ungrouped data. So for the ungrouped data we will discuss these two types of quantiles in this video lecture. And in the coming second video lecture of week 6, I will tell you about quartiles, deciles, and percentiles for the group distribution data and its graphical presentations. So dear students, first of all I would like to tell you about the quartiles. Quartiles are the numbers which divide the data into four equal parts. Then these numbers called quartiles: Q1, Q2 and Q3. Q1, Q2 and Q3 are the numbers which divide the data into four equal parts, which divide the range data into four equal parts. Similarly, deciles are the numbers which divide the range data into 10 equal parts: D1, D2, D3, D4, D5, D6, D7, D8 and D9. Suppose you see over here, this is the whole data. At this position there is a number which called D1, this number D2, this number D3, D4, D5 and similarly D9. So there are 10 equal parts: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Deciles are the numbers which divide the data into 10 equal parts: 10%, 10%, 10%. Percentiles, the numbers which divide the rank data into 100 equal parts: P1, P2, P3 up to P99. So these are the partitions numbers to divide the data into three equal parts. These numbers called quartiles. In the numbers which divide the rank data into 10 equal parts are called deciles. In the numbers which divide the data into 100 equal parts are called percentiles. So in the coming slides I will tell you the procedure how to find these three quartiles, Q1, Q2 and Q3, which divide the rank data into four equal parts in group form and in ungrouped form, and deciles and percentiles. First of all, I would like to tell you about these three numbers again. Quartiles, deciles and percentiles are called fractiles. Fractiles mean partitions data into approximately equal parts. These three characteristics, quartiles, deciles and percentiles, divide the data into approximately equal parts. Quartiles are three numbers which divide the data into four equal parts. Deciles are 9 numbers which divide the data into 10 equal parts. Similarly, percentiles are 99 numbers which divide the data into 100 equal parts. Now, quartiles. A quartiles divide the sorted data
the arranged data into 4 equal parts so that each part represents 1 by 4 of the data sets. You see over here, this is the Q1, this is Q2, and this is Q3. So there are 4 partitions: 1, 2, 3, and 4. Actually, these are 3 numbers: Q1, Q2, and Q3. But these 3 numbers divide the data into 4 equal parts. This is the first part, this is the second part, third part, and fourth part. Like you see over here, these blank white color represent Q1, Q2, and Q3. So the data divide into 4 equal parts. These numbers called quartiles, and each part represent 1 by 4 of the data set. Now you see over here, like decile 10%, 10%, 10%, and 10%. Similarly, quartiles divide the data into 4 equal parts: 25%, 25%, 25%, and 25%. These two parts are called interquartile range. These two parts are called interquartile range. In we can find the interquartile range, the largest number minus smallest number is called actually the range. In the coming video lecture, inshallah, we will discuss the range. So range is actually found by smallest number from the largest number. Subtract the smallest number from the largest number is called a range. So these two partition you see over here by the yellow color, these two partition represent the interquartile range, and interquartile range can be found by Q3 minus Q1. For example, to find the median Q1, Q2 in a shortcut way, the data set 2, 8, 5, 3, 10, 6, 7, 9, and 1. First of all, arrange the data in order. Write the data in order form: 1, 2, 3, 5, 6, 7, 8, 9, 10. And you see over here 4, 5, 6, 7, 8, 9. There are 9 numbers. So 4 number, divide the data into 2 parts first of all, because finding the median Q1 and Q2, we need in this data 3 characteristics: median of the data, Q1 of the data, and Q2 of the data. So in the first part, we obtained 4 numbers. This is actually the first portion, the first part of the data. And this is the third part of the data. And this form, this is actually Q3. Now Q2 actually the median, and this is the median Q2. Q2 is actually 6, and 6 is the median. 4 terms on the one side and 4 terms on the other sides. So this is the center point, and the center point is called the median. And dear students, Q2 actually represent the median. Now for raw and for ungrouped data, how to find the quartiles Q1, Q2, and Q3. First of all, arrange the given data in increasing order and use the formula for Q1 and Q3. Then quartile deviations. First of all, if we need Q1, Q2, and Q3, but if we need the quartile deviations, the quartile deviations formula is Q3 minus Q1 divided by 2. So in the raw or group data, we can find the quartile deviations. A Q3 minus Q1 divided by 2 actually called the quartile deviations, where Q1 n plus 1 divided by 4 item, and Q3 n plus 1 divided by 4 item also. So for example, to compute the quartiles for the data 25, 18, 30, 8, 15, 5, 10, 35, 40, and 45. First of all, arrange the data in increasing order: 5, 8, 10, 15, 18, 25, 30, 35, 40, and 45. So first of all, find Q1. Q1 is equal to n plus 1 divided by 4 item. This is the position of the Q1. The position of Q1. Q1 means the number which represent the first part of the data. So there are 10 numbers. 10 plus 1 by 4, which is equal to 2.7. And 2.7 mean second items plus 3 by 4 into third items minus second items. The third items is 10 and the second item is 8. So, and the second item is 8. 2.57 item. This is the position of Q1. The position of Q1 2.575 means that second item plus 2.75, second items plus 3 by 4 into third items minus second item. So the second item is 8 and 3 by 4 into 10 minus 8. 10 minus 8 mean 2, 3 by 4 multiplied by 2, which is equal to 1.5, and 8 plus 1.5 is equal to 9.5. So here is a number 9.5. 9.5 represent Q1, and this is the first part of the data. Q1 is 9.5. So 9.5 represent the first quartile for this data. Now to find the third quartile for the data. So dear students, for the third quartile you see over here, this is equal to 3 into n plus 1 item. 3 into n plus 1 is the third quartiles. So the third quartile is equal to 3 multiplied n plus 1 by 4 item. And similarly for the fourth quartile, 4 into n plus 1 divided by 4. And for the second quartile, 2 into n plus 1 divided by 4, because n is odd and n is even. N is even in these situations. So for the quartiles, you see over here, these are the Q1 formula, n plus 1 divided by 2. For Q2, 2 into n plus 1 divided by 4. For Q3, 3 into n plus 1 divided by 4. And for Q1, n plus 1 divided by 2. For Q2, n plus 1, 2 into n plus 1 divided by 4, and for Q3, 3 into n plus 1 divided by 4. I want to tell you again, the position of Q1 can be found by the position formula, n plus 1 divided by 4, Q2, 2 into n plus 1 divided by 4, Q3, 3 into n plus 1 divided by 4. So for the Q3, 3 into n plus 1 divided by 4. So n plus 1 mean 10 plus 1 by 4 multiplied 3, and 10 plus 1 by 4 mean 11 by 4, which is equal to 2.75. In the previous slides you see over here 10 plus 1 divided by 4 mean 2.75, and 2.75 multiplied this 3, so 8.25 item. So this 8.25 item mean 8th item, and the 8th item is 35. 1, 2, 3, 4, 5, 6, 7, 8. 8 at the 8th position we obtain 35 plus 1 over 4 into 9th item minus 8th item. 9th item minus 8th item. The 9th item is 40 and the 8th item is 35. So 1 over 4 into 40 minus 35. So 35 plus after simplifications we obtain 1.25, and 35 plus 1.25 is equal to 36.25. So Q3 third quartiles of this data is 36.25. Here third quartile is lies. Now the quartile deviations, Q3 minus Q1 divided by 2. Q3 values is 36.25 and the Q1 value is 9.5 divided by 2, which is equal to 13.75. So dear students, up to this slides you see over here, these are the quartiles. Quartiles are the three numbers which divide the data into two equal parts, and you see over here these are the formula. First of all, arrange the data in increasing order, and then for Q1 find the position of Q1. The position of Q1 will be equal to n plus 1 divided by 4 item, and the position of Q2, 2 into n plus 1 divided by 4, and the position of Q3, 3 into n plus 1 divided by 4. And similarly uh, in the Q3, 3 into n plus 1 divided by 4 items, and you see over here in this example 3 into n plus 1 divided by 4 obtain 8.25. 8.25 mean this 8 represent the eighth number items, and 8 items plus 1 over 4 into ninth item minus 8 items. Ninth item minus 8 items. So the overall, after overall calculations, the 8 term is 35, the 9 term is 40, and the 8 term is 35. And now after simplifications we obtain the Q3 is 36.25. So for the quartile deviations, this is the simple formula Q3 minus Q1 divided by 2. And in the next video lecture we will discuss this quartile deviations for the dispersions, for the variance, and for the range. Now another partitions which called deciles. The values which divide an array into 10 equal parts are called deciles. The first, second, third, fifth, and ninth deciles by respectively. The fifth deciles correspond to the median. The second, fourth, sixth, and eighth deciles, which collectively divide the data into 5 equal parts, are called quantiles. Deciles for ungrouped data. The decile for ungrouped data formula, deciles for ungrouped data will be calculated by this formula D1. D1, the value of n plus 1 divided by 10 item. D2, the value of 2 into n plus 1 divided by 10 item. Similarly, the value of D9. D9 is the value of 9 into n plus 1 divided by 2 item. So, dear students, these steps are very interesting. First of all, find the positions, and according to the position you can find the values of the position. For example, this is represent the position, this is also represent some position, this is also represent some positions. So putting the value of the number of terms in this formula, you will get the positions, and then according to the positions pick the value of D1, D2, and D3. D1, D2, D3, D4 actually represent the values, and these values divide the data into 10 equal parts. Now, for example, we want to calculate D2, D3, and D7 from this data. 20, 28, 29, 30, 36, 37, 39, 40, 53, 54, 55, 58, 61, 67, 68, 70, 74, 81, 82, and 93. So, dear students, first of all, arrange the data in increasing form. 20, 28, 29. You see over here, this is the red arrangement of the data in the increasing form. So, dear student, in this example, we need decile 2, second decile D2. So, first of all, find the position of D2. D2 is the value of 2 into n plus 1 divided by 2 position. So 2 into 20. 20 is the number of terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 and 10. There are 20 terms. So 2 into 20 plus 1 divided by 10 mean 4.2 items from below. So the value of the fourth item, you see over here the value of the fourth I want to highlight is the value of the fourth item is 30. 1, 2, 3, 4. This is the fourth position value. The value of the fourth item is 30, and that of the fifth item is 36. So this is the fifth items. Thus the second decile is a value of 0.2 of the way between 30 and 36. The fifth decile will be 30 plus 6 into 0.2 is equal to 31.2. Therefore, this is equal to 31.2. So, the D2 value, this position, 4.2 position item, the value of the fourth item is, you see over here in this slides, we need second, third, and seventh decile. So, for the second decile value, first of all, Find the position 4.2 item from below. The value of the fourth position item is 30 and data of the fifth item is 36. So the fifth position value is 36 and the fourth position value is 30. So 30 plus 6. 30 plus 6 into 0.2. 30 plus 6. The second decile is a value 0.2 of the way between 30 and 36. The fifth decile will be 30 plus 6 into 0.2, which is equal to 31.2. Now decile number 3, D3, and in this example we need second, third and seventh decile. For the third decile, the position value, the value of the 3 into n plus 1 item, 3 into 20 plus 1 by 10, 6.3. So the value of the sixth item, the value of the sixth item, the value of the sixth item you see over here, the value of the sixth item 1, 2, 3, 4, 5, 6. The value of the sixth item is 37 and the value of the seventh item is 39. So thus the third decile is 0.3 of the way between 37 and 39, and the third decile will be 37 plus 2 into 0.3. And you see over here for the second decile 30 plus 6 into 0.2. 30 plus 6 into 0.2. And now for the third decile is 0.3 away of between 37 and 39. So the third decile will be 37 plus 2 into 0.2, hence 36.6. So D3 is a 37.6. Now D7. The value of D7. 7 into n plus 1 divided by 10 item. 7 into 20 plus 1 divided by 10, which is 14.7. The item from below. The value of the 14 item is 67. You see over here 67. And that of the 15 is 68. Thus the seventh decile is 0.7 of the way between 67 and 68, which will be 67 plus 1. And you see over here why we need here to multiply to 0.3. Actually the gap between these two numbers is 2. 37 to 39, 2. So the third decile is 37 plus 2 into 0.3. And for the second decile, the gap between the 30 and 36 is 6. That's why we add these numbers, 30 plus 6 into 0.2, 6 into 0.2. So this point is very important. So this is actually the second decile. The second decile is equal to 30 plus 6 into 0.2. So dear students, first of all, note the gap, the difference between these two numbers. So the difference between these two numbers is 30. Similarly, for the quartiles, you see over here in the previous slides, for the quartiles 0.45, 0.25. So the 8 item plus 1 by 4, 0.25 mean 1 by 4, 9 minus 8. For the quartile, the difference between these terms, ninth item minus 8 items. So you see over here from this calculations, the third quartile's item is 8.25 item is 8 item plus 1 over 4 into 9 minus 8. And for the decile, these points are very interesting. That 4.2 for decile number 2. 4.2 mean the value of the fourth position, which is 30 in this example, and the value of the fifth position is 36. Thus, their second decile is the value of 0.2 of the way between 30 and 36. So 30 plus 6, this 6 is obtained from the gap of these two numbers. So 30 plus 6 into 0.2. And similarly, this you see over here, 37 plus 2 into 0.3. So 0.3 you see over here, the fraction part is 0.3. The sixth item is the sixth item 37, and the seventh item is 39. And between 37 and 39 there are two gaps. So the third decile is equal to 37 plus 2 into 0.2. So the third decile is a 37.2. Now the seventh decile position 14.7. The 14th item is the 67 and the 15th item is 68. So between 67 and 68 there are one gap. So the decile 7 decile is 0.7 away of the between 67 and 68, which will be as 36 plus 1 into 0.7. So after calculations we obtain 66.7.